Hi guys, and welcome to Preliminary Chemistry and the Chemical Earth video series. In this particular video, we're going to look at one of the first times we're going to look at ionic compounds. So in the last video, we had a little bit of a look at atomic structure, and we identified the key components of the atom as the nucleus, which contains the protons and the neutrons, and then outside of the nucleus, these electrons. And the electrons are there primarily to help us to determine what happens chemically to different types of atoms. The electron configuration, or the order in which the electrons are distributed around the nucleus, gives us a clue as to what sort of ions are going to form. So for the first one of these, we're looking here at sodium. We have 2 electrons in the first shell, 8 electrons in the second shell, and just that 1 electron in the outermost shell. Contrast that with the chlorine atom, which is over here, and we have 2 and 8 and 7 in the outermost shell. Now we're looking for stable octets, so we're looking for 8s. And so the easiest way for us to make an 8 here is for the outer shell electron from the sodium to be captured by the chlorine. Now, how does this happen? Well, basically, as these 2 atoms move very close together, the nucleus of the chlorine, which has a 17 proton charge, or a 17 plus charge, exerts a greater force of attraction, being an opposite and large charge on the electron, than the nucleus in the sodium atom, which is just the 11 plus. And so it attracts the electron away. Of course, once it does this, the sodium ion that's formed, a sodium ion Na plus, just 1 plus because it's lost 1 electron, shrinks, so it becomes a little smaller. The chlorine ion, the chloride, becomes slightly larger as that extra electron is just pushing against the other electrons in the cloud, and so we have a slight change in the size of each of these species. But primarily what we have is 11 protons and just 10 remaining electrons in our sodium ion, and therefore it has an excess of 1 proton, hence it's a 1 plus charge. For the chlorine, it has 17 protons, but it now has 18 electrons, so it has an excess of 1 electron, and hence its negative charge. We can use this understanding of how electrons are moving from one species to another to explain some of the important formations of ionic compounds. So ionic compounds are formed when 2 ions, 2 oppositely charged ions, attract one another. So here again we have sodium ions, sodium and sodium, and we know each of these is going to lose 1 electron and form a sodium 1 plus. But over here we have oxygen, and oxygen has a 2,6 arrangement as its electron configuration. That means that the oxygen actually wants to gain 2 electrons, not just the 1. And because each sodium can only donate 1, it's going to need 2 sodium atoms in order to become stable itself. This means that when we write the formula, we need to identify the fact that it's taken 2 sodium atoms to stabilize that oxygen atom, and therefore our formula is Na2O. You can identify where each of these ions are in the periodic table, and I've already told you before that you are going to get a periodic table for each of your key assessment tasks, including any of your major exams. So this is going to be a critical tool, and the more things you can do with it or identify with it, the easier it's going to be for you. If you start as just a good practice each time, above the groups in the periodic table, the groups are going down and the periods go across. So above each of the groups, if you start from the first group of metals, +1, +2, we're going to leave this big group of transitions in the middle as a +2 as well, although some of them can change. A +3, we get to carbon as the top one, which we're going to call plus or -4. Most of these are actually involved in covalent species, the carbon and the silicon in particular, but it's possible that they can be ions as well. And then -3, -2, -1, and 0 for the noble gases. The noble gases do not react and already have the stable octet. So this gives us from the periodic table an idea of how each of these different species are going to combine in different reactions. Now, it's not perfect. We know, and if we don't yet, we're going to continue to find out more and more often in chemistry. There's lots of exceptions to different rules, but this gives you a good general overview of what's happening in terms of the elements in the periodic table. And then just finally, a little bit of a starter look at ionic bonding. So an ionic bond is a bond between oppositely charged ions, oppositely charged ions. Positive ions are called cations, and negative ions are called anions. The problem that we have is if one sodium donates its electron to one chlorine, and as a result of that, the sodium becomes positive and the chlorine becomes negative, this positively charged ion will attract negatively charged chlorines in all directions. So it won't just attract the original chlorine with which it exchanged the electron, but it will attract them in all directions. So we get a network arrangement, a network or an array of ions equally distributed around each other. So you can see that these ionic bonds exist between a positive ion and a negative ion in all directions, 3 dimensions, up, down, left, right, and into and out of the page. We will have a little bit more at ionic bonding later on in this course. So thank you for watching.